Hello, I'm Brian Price, author of Crime Writing, How to Write the Science, and in the second of my videos, offering tips on science to crime writers and readers, I'll be looking at poisons. So I'll start with asking the question, what is a poison? Basically, a poison is a chemical which can do you harm if you take enough of it, usually by disrupting the chemical processes which go on inside our bodies and keep us alive. Poisoning can be acute, where you get the effects quickly after a single largish dose, or they can be chronic, where small doses of a poison build up over a period with fatal results. Of course, sometimes you can have both. Arsenic is an acute poison if you take a large quantity. It's a chronic poison if small amounts are given over a prolonged period. And both these methods have been used to kill people in the past. Poisons can be perfectly natural. The fact that something is natural doesn't mean it's harmless. If you look at plant poisons like atropine, aconite, digoxin from foxgloves, these are perfectly natural and also very dangerous. They could be the metal poisons like mercury, lead, thallium, or they could be completely synthetic like Novichok and its nerve agent relatives. So let's look at a few sources of poison. This is monkshood, source of the deadly poison aconite. Here's foxglove, pretty in pink but source of the poison digoxin, also useful medicine. Here's belladonna or deadly nightshade, source of the medicine and poison atropine. And this is the castor bean plant, the seeds of which produce the extremely dangerous poison ricin. And these are the seeds of the plant that produces strychnine. Not all poisons come from plants. Many metals are poisonous, and here's an example, mercury. Too much of that, it'll send you mad as a hatter. Here's another toxic metal, lead, also very bad for the brain. Paracetamol, acetaminophen in the States, a valuable painkiller, but take too much and you're in serious trouble. Alcohol in its various forms. Too much at once, it'll kill you. Too much over a prolonged period, and you've got chronic poisoning. These are apricots, the stones of which contain a chemical which releases cyanide. This might surprise you, it's water. Drink too much of this all at once and it could kill you. As the 15th century philosopher and scientist Paracelsus said, rather more elaborately, it's the dose that makes the poison. So how long does it take for poisons to work? Well, the speed at which poisons work depends on how you take it in. If it's injected into a vein, the effects can be felt within a few seconds. Similarly, if you inhale something like hydrogen cyanide gas, it will exert its effects very quickly. Something injected into a muscle will take longer. It's got to get out of the muscle, into the bloodstream, and then hit its target. If you swallow a poison, it can take 15 to 20 minutes to clear the stomach, longer if it's got a lot of food in it. But once it's clear through the stomach, it can be absorbed in the small intestine. A few poisons are absorbed through the stomach, but most have to wait till they get to the intestines. And of course, once it's in the bloodstream, the effects can be felt fairly quickly. There are some exceptions. Ricin is one. Because of the way it works, it can take several days to kill you. And of course, chronic poisoning with the repeated doses can take weeks before it kills you. So what are the most deadly poisons? Well, it's difficult to give an accurate ranking for all the poisons you come across in literature or in real life, but there are a few general things which could be said. Firstly, top of the list is a particular form of the botulinus toxin. This isn't the same stuff as you have injected into your face to remove wrinkles, but it is a relative, if you like. That's lethal in millionths of a gram quantities. Then you've got things like Novichok and the related nerve agents. A very small amount of that will kill you. And then there's the plant poisons abrin and ricin, which again, a very small quantity can prove lethal. Turning to animals, there's the tetrodotoxin present in the pufferfish. A few milligrams of that can be lethal. Aconite, a plant poison, the queen of poisons it's been called, is also pretty close to that. and then you move down to things like cyanide and strychnine, arsenic and the metal poisons. Where do you get poisons then? So, how can your character get hold of poisons? Well, back in Agatha Christie's day, it was relatively easy. You could go into a pharmacy, sign the poisons book, and walk away with huge quantities of cyanide, strychnine, arsenic, all for the declared purpose of killing pests. It's not so easy these days. Some of these chemicals have been banned, and for many of them you need a license, and it's not that easy to get hold of one. That's the UK position, of course. It may well be different in other countries, but I'm sure there are some restrictions. It's possible, I suppose, for a character to get stuff from the dark web, but I always tend to feel that's a bit of a cheat in a plot. There's always the possibility of using agricultural pesticides, but most of those have been discontinued if they're particularly dangerous. So where can somebody get hold of these chemicals? Well, there's a couple of options. One is to find them in a disused shed or agricultural building where there might be something lethal from times past. Another possibility would be an old medicines chest left in an attic for many years, where you'd possibly find things like strychnine and other dangerous materials. It is possible to get some of these materials out of plants, but that can be risky, and you do need a fair bit of chemical knowledge to do it properly. Certainly trying to extract ricin or aconite without some reasonable levels of skills and protective equipment could be very dangerous indeed. Where do writers occasionally go wrong? So there's a few common mistakes which I point out which authors sometimes make when discussing poisons in their books. Cyanide is one where people do often go slightly wrong. Firstly, cyanide does not make you blue if you're poisoned with it. It's nothing to do with the cyan colour in the ink cartridges you might be familiar with. If anything, someone poisoned with cyanide will go slightly pink, because cyanide stops the cells using oxygen. Oxygen stays in the blood, which remains bright red and looks pinkish through the skin. Another error is where people sniff someone's breath if they've been poisoned with cyanide and say, bitter almonds, that's cyanide. Well, there's 2 points there. Firstly, it's not a very good idea to sniff the breath of someone who's been poisoned with a large amount of cyanide. You might be poisoned yourself. Pathologists doing a post-mortem with someone suspected of cyanide poisoning will do so with very efficient ventilation to make sure they don't succumb while doing the job. Another point is that half the population can't smell cyanide anyway, so it's probably not a good test in the first place. Another area, it relates to the analysis and the toxicological results of a number of poisons. Things like potassium cyanide split, they ionize as it's called, when they're dissolved and in body fluid, so you get the potassium going off in one direction and the cyanide going off somewhere else. If you're doing a toxicological analysis, you'd find cyanide. You wouldn't notice the potassium because there's plenty of the potassium in the body anyway, and it would be masked. So if somebody says, I found potassium cyanide in the stomach or in the bloodstream, no, they didn't. They'd have found the cyanide. And the same thing would apply to other drugs which have a sort of 2-part name like morphine sulfate or strychnine hydrochloride. You'd find that the main part, the poisonous bit, but the sulfate or the hydrochloride wouldn't be picked up. Another area where people do sometimes get things wrong is in speed of action. As I said before, most things have to be absorbed by the small intestine. So the scenario where somebody eats a poisoned bun at the vicarage tea party and falls over immediately just wouldn't happen. It can take a lot longer, as I've said already. Another area where people do sometimes go wrong is with dose, and some poisons do need quite a large dose to have their effects. Ethylene glycol, for instance, you need about 100 mils to kill you. And I did see a television program where somebody was poisoned with ethylene glycol in chocolates. And that's an awful lot of chocolate to accommodate 100 mils of ethylene glycol. I hope you found these tips interesting and helpful. There's plenty more on poisons on my website and in the book. Next time, I'll be looking at how to knock people out. Thank you for watching.